Okay, so we've moved through the red blood cells. Now we're at the white blood cells. White blood cells are our body's defenders. They are a part of our immune system. So we'll talk a little bit about them now, but we'll talk a whole lot more about them when we get to the immune system chapter. Okay, so remember, white blood cells are considered complete cells because they do have nuclei and organelles, but they make up very little percentage of the total blood volume, right? Less than 1%. We remember there's about 45 to 4,800 to about 11,000 cells per microliter. So that's a tiny, tiny bit of blood, okay? So if you have a higher number than that, we say that someone has leukocytosis. So if a person has higher than 11,000 white blood cells per microliter, then they are in leukocytosis. That can be a result of just a normal response to an infection. Again, like I said, these cells are important for our defense against disease. And we have 5 types of white blood cells. We saw them briefly earlier. Now we're going to delve into them now, right? There are 5 types: neutrophils, lymphocytes, monocytes, eosinophils, and basophils. And you see I've written out something here. It says, never let monkeys eat bananas. Okay, that's a good way to remember the cells in order from most abundant to least abundant. So never let monkeys eat bananas. Okay, decreasing abundance in the blood. Okay, white blood cells can be grouped into 2 main categories. They can be considered granulocytic or agranulocytic. So anytime you see the term A, it means without. Okay, so agranulocytes don't have visible granules in their cytoplasm when you stain the cells with red and blue stain so that you can see them on a slide. Okay, granulocytes do have granules, and those are going to be little sacs of chemicals in the cytoplasm of these cells. And they are, like I said, visible when you look at the cell under a microscope. So 2 cells are agranulocytes and 3 cells are granulocytes. And you'll notice that the agranulocytes are kind of easy to remember. They go together because they end with the term cyte. Lymphocytes and monocytes are agranulocytes. Granulocytes are going to be the phils: neutrophils, basophils, and eosinophils. Okay, so let's talk a little bit about white blood cells in general, and then we'll get into greater detail about each type, right? White blood cells are able to move. They move by amoeboid, and this is misspelled, amoeboid. I'm looking at that, I'm like, that doesn't look right. They move by amoeboid movement, okay? So what that means is they can kind of stick out parts of their cytoplasm and move and inch themselves forward. So they move. They don't just float in the bloodstream. They can move through tissues. Okay, so they can leave the bloodstream and move through tissues. And they do that in a process that we call diapedesis. We'll talk more about this term and what this means when we talk about the immune system. But because they are movable, okay, and because they have roles as the body's defenders, they get attracted to foreign materials or dead cells and tissues, and they will migrate there to help protect us from those things. The process of that migration towards a chemical scent is called chemotaxis. The term taxis means movement. So this is a chemical movement towards, or a movement of these cells towards a type of chemical. All right. So here we have the formed elements. Remember, this is not drawn to scale because red blood cells are about 99% of all formed elements, right? Red blood cells are 99% of all formed elements. And when we look here, we see the leukocytes. We see the total white blood cell counts anywhere from 45 to 4,800 to almost 11,000. Okay, and then we see in here, you can see these different shades of blue here. You can see their abundance, right? So neutrophils are going to be about 50 to 70% of all white blood cells. So by far the majority, okay? Then we have lymphocytes, 25 to 45%. Monocytes, 3 to 8%. Eosinophils, 2 to 4%. And basophils are the very rarest white blood cells. They're hard to find them. Okay, they're very rare because remember, white blood cells are less than 1% of all cells in blood, And this is 0.5% of that. So it's super, super rare cells in the blood. So what we're going to do is we're going to look at each type of white blood cell, talk a little bit about their functions. And like I said, we're going to come back to the white blood cells more when we discuss the immune system. So the first group, we'll spend some time talking about the granulocytes. And remember, we said they have visible granules in their cytoplasm upon staining. So let's look over here first. Let's kind of zoom in here and look first. This is a neutrophil. This is a neutrophil here too. These cells surrounding are red blood cells. Here's red blood cells, okay, neutrophil, okay. And when you look particularly at this image, you could see the little polka dots in the cytoplasm, right? Those are the granulocytes. Those are the granules, those little pockets of sacks of chemicals in the cytoplasm, okay. The reason why neutrophils are considered neutral or called neutrophils is because when you stain blood and you want to look at it on a microscope, you dry some blood on a slide and you dip it into a red dye and you dip it into a blue dye. And what you get are combinations of red, blue, and purple. And so the neutrophils kind of have like a light lilac or sometimes even clearish cytoplasm, so they're considered neutral. All neutrophils have multi-lobe nuclei, so they look like they have lots of different nuclei, but it's one nucleus with lots of lobes to it, okay? So again, we said these are the most numerous white blood cell. They typically have 3 to 6 lobes of the nucleus. Let me add that. And here's their function right here, right? These are bacterial slayers. They are our first defenders. Because they're so numerous in the blood, if you have any kind of trauma or infection, these things are going to be there first, and they're going to eat bacteria like crazy. So these are actively phagocytic cells. They are phagocytes. Okay, next, moving on to the eosinophils. Eosinophils really stain reddish in their cytoplasm, and the name of the red dye that we use to stain blood smears on slides is called eosin. So that's why they have this name, okay? So they look really red in the cytoplasm, and we look here at the nucleus. The nucleus always has typically 2 lobes to it, and sometimes people say they look like earmuffs, or maybe they look like big barbells, okay? So here is another eosinophil. This is a much better picture. We'll try to give you beautiful pictures like this so that you can make it really clear and obvious what cells these are, okay? Their granules stain red, and they are important for the attack against parasitic worms, okay? Only about 2 to 4% of white blood cells, so fairly rare. Okay, the most rare of all, right? The basophils. Look at basophils. When you look at them, it's hard to even see the nucleus, right? Because their granules stain super, super dark purple, even kind of purplish black, okay? And so these basophils that you see here, their granules are super dark. Those granules are going to contain histamine. And histamine is what we call a vasodilator. So again, getting back to the idea, we're going to come back to a lot of these things later, but they make blood vessels dilate, so they increase in size. And what that does, particularly when you are having an infection or you're suffering from inflammation, it makes areas swell, right? Makes them red, okay? And you might say, well, that's not a good thing. We don't want that. But actually, it is a really good thing that we do this vasodilation because it brings more white blood cells to the area to help protect us. So histamine is a chemoattractant for other white blood cells. So when basophils start releasing histamine, other white blood cells come to the area that could be damaged or have an infection. Okay. All right, so those are the granulocytes. Let's move on to the agranulocytes. Agranulocytes, first one are the lymphocytes, about 25% or so of white blood cells. When you look at the agranulocytes, they're going to both stain very similarly. They just look kind of purple. The nucleus is going to be purple. There's no real change in colors here. But the nucleus for a lymphocyte is going to take up most of the cell, right? The very little cytoplasm, and most of the cell has this big nucleus, okay? Most of these are not found in the bloodstream. So they're really numerous in the bloodstream compared to other white blood cells, and they're still not the most numerous in the bloodstream. Because they live also in lymph tissue. Okay, there's different types of lymphocytes. There's actually 3 different types of lymphocytes. We'll talk more about these later, B cells and T cells. Okay, B cells produce antibodies, and T cells are important for something called cell-mediated immunity. Again, we'll discuss more of this later. Okay, last agranulocyte, the monocytes. Okay, monocytes kind of have this horseshoe-looking nucleus, as you can see here, kind of a kidney bean or horseshoe-looking nucleus. These are the biggest white blood cells. These cells are kind of interesting because in the bloodstream, they're called monocytes. But when they leave the bloodstream, we call them macrophages. You've heard of those before, right? These are big-time phagocytes. So they eat all sorts of stuff. They're the biggest white blood cell. These things can eat a tremendous amount of material. So neutrophils are typically the first responders that get to the area of infection first. And then macrophages come second and kind of clean house, clean up after repair has started occurring. So there are leukocyte disorders. Okay, there could be an overproduction of leukocytes, which you might say, oh, that's not a bad thing, right? That means that we're going to be protected and not have as much disease, but that's not true. Okay, if you produce too many white blood cells, it's likely that you're not producing enough red blood cells, right? So production of too many white blood cells in the red bone marrow is called a leukemia, and that's a type of cancer. They can come in different forms. We can say you can have an acute leukemia or chronic leukemia. And what changes that differentiation there, what distinguishes those two, is what type of cells dividing without control in that hematopoiesis pathway. Additionally, you can produce too many white blood cells in mononucleosis, okay? In mononucleosis, we typically produce a huge number of macrophages, monocytes, and then macrophages. And they start eating the good cells too, and that's not good. They start eating red blood cells. And people with mononucleosis oftentimes will feel fatigued or very tired because they don't have a lot of, they don't have enough red blood cells to give them oxygen for production of energy. In the reverse, you can have leukopenia, which is too little white blood cells, so too few white blood cells. This could be due to chemotherapies or other drugs.